Sounds good. Should I begin? All right, great. Well, thanks everyone for joining us. My name is Rebecca Charbonneau. I am a historian of science. I currently work at the American Institute of Physics, and I'm also the author of Mixed Signals: Alien Communication Across the Iron Curtain, which is a book that tells the history of the development of the search for extraterrestrial intelligence during the Cold War period. I work primarily in the world of astronomy. I've worked at places like NASA. I've worked at Harvard Smithsonian Center for Astrophysics, and I'm currently calling to you from inside the National Radio Astronomy Observatory in Charlottesville, Virginia. And today we're going to talk about one of my favorite topics in the world. It's a really, really fun bit of history, and it's on the origins of the post-detection protocol in the search for extraterrestrial intelligence. Now, you may quite reasonably ask, what is a post-detection protocol? You might remember, if you happened to join us for the last lecture I gave, kind of a brief history of the search for extraterrestrial intelligence, or SETI, during the Cold War period. Today we're going to talk about how scientists during that period shaped the way we plan for eventual contact with alien civilizations. And that plan is a post-detection protocol. You might be kind of familiar with the term. Post-detection protocols are meant to happen after the successful detection of aliens, right? So in other words, once somebody finds what they believe is evidence of aliens, what happens next? This is a very popular concept in a lot of science fiction movies and television shows. For example, I have just kind of three clips here from different movies and TV shows. Like on the upper left-hand corner, we have a scene from Doctor Who. An alien spacecraft is hitting the Thames River in England. And in the aftermath, British government officials and public leaders are rushed into 10 Downing Street to a secret room to discuss the next steps now that Britain has made contact with ET. The picture below that is from the 2008 remake of The Day the Earth Stood Still. And after they make a detection of an alien life form, astrobiologists, physicists, and other world leaders and experts are really quickly rushed into helicopters and private cars by mysterious government agents so that they can all be in a kind of a situation room deciding how to handle the issue of first contact. And then my favorite is a clip from a movie, the movie Contact, starring Jodie Foster, which came out in the 90s. In Contact, the National Security Council takes control of the radio telescope Arecibo after radio astronomers successfully detect a coded extraterrestrial message. So you can probably see the connection here, which is that the public or the media seems convinced that matters of ET, of extraterrestrials, clearly concern governments and, of course, experts such as scientists. And we really expect that governments and scientists will take a leadership role and have a plan in the aftermath of detecting aliens. In fact, you can even see that in the classic cliche, take me to your leader, right? There is an assumption that there is a plan with the people in charge. And even more so, some people think that plan is a secret, right? So again, grabbing from science fiction, movies like Men in Black, see there on the left, show agents wiping people's memories to hide the truth of extraterrestrials, the truth that Earth is part of a bigger cosmic neighborhood. And in real life, people have long believed that Area 51, a military base in Nevada, is where the US government hides alien ships or even alien bodies. So where does this belief come from? There seem to be two big assumptions at play. The first is that if we find signs of intelligent life out there, governments are involved, and two, that they'll keep it a secret from the public. But that's always seemed to me a little bit strange. For one thing, most scientific discoveries aren't kept secret by governments. Even the few government projects that were kept secret, things like Project Manhattan during World War II, they didn't stay secret for very long. It's very hard to keep secrets. And even in the case of like the Manhattan Project, the secrecy had a very specific purpose: winning the war, right? Trying to beat the Germans. So what would be the reason to keep aliens a secret? Some, like in the movie, have suggested that maybe it's because it would cause worldwide panic. Maybe people can't handle the information of what's out there. But if you look at other examples from human history, even recent history, like with the COVID-19 pandemic, we got plenty of panic-worthy information from our governments. And in fact, sometimes governments use panic-worthy information for their own purpose, either to strengthen control or for political motivations. Governments usually don't try to protect their populations from information like that. So that's why I don't think panic is a very convincing reason for why the detection of aliens would be top secret. Instead, I think this belief in the secrecy surrounding the detection of extraterrestrials really comes from the time when SETI began, in the Cold War period. It was a time when people were constantly worried about spies, classified projects, and what their own governments were hiding. It created a culture of secrecy and distrust, and that feeling stuck around even when it came to science. So, at the heart of post detection protocols, what we ever do if we find a real alien signal is a big question about trust. Who gets to know? Who gets to decide what to do next? And that's what this talk is going to be about. So it all starts, the first post detection protocol was developed in 1989 by an international group of scientists at the International Academy of Astronautics. It's a global organization. And they created this declaration of principles concerning activities following the detection of extraterrestrial intelligence. It's kind of the first example we have of a post-detection protocol. Now, the document looks like this and more so. I'm not going to make you read it. It's very wordy. But in brief, it basically sums up the following pointers. First, if you make detection of what you think is evidence of aliens, first you have to confirm it. Before anything is said publicly, the scientists have to make sure that it's not a false alarm, that this actually is evidence of extraterrestrial intelligence. That's the scientific method at work. The second thing is to first quietly tell other scientists. That way they can double check their work. Peer review is a big part of the scientific process. Then critically, if it still looks real, you have to report it internationally. Organizations like the United Nations and other global scientific organizations have to be involved. Then, once that's been done, you announce it publicly. The team who found it gets to announce it first. Finally, you have to share the data. The idea is that if a message from aliens was sent to Earth, it belongs to all of Earthlings. It can't belong to any one nation or individual. So once it's verified, it has to be made available to all of the world's scientists and the public. You also have to preserve the evidence. Lots of recordings and copies have to be made of the signal so it can't be lost, or the artifact, or whatever it is. And you also have to work to protect it if it's still coming to Earth. Prevent it from being jammed, for example, by like anti-satellite weaponry. And then finally, you cannot respond. If a message is being sent to Earth for all of Earthlings, no one person can decide what we are going to say back. So that is, in 1989, what they developed, the kind of the protocols. It's a loose set of lists in order to guide someone who makes a discovery. And the idea is that any one scientist happens to make a discovery, they'd first look here before deciding what to do next. The woman who helped spearhead the development of the protocols is the woman pictured here on the left. Her name is Jill Tarter. I have a picture of her here with Jodie Foster because actually in the film Contact, Jodie Foster's character, Ellie Arroway, who's the radio astronomer who finds the signal, was actually based off of the real-life Jill Tarter, who was a radio astronomer who has spent her career trying to find evidence of extraterrestrial intelligence. I had an opportunity to speak with Jill in her home a few years ago, and I asked her about the development of the post-detection protocols and why they came up with the idea to do it in the first place. And she specifically said it was because of the Soviet Union. They were concerned that if the Soviets made a detection, that they wouldn't announce it, that they would hide it, that again, that there would be this culture of secrecy. And so they wanted, obviously they can't control what world governments do, but they wanted to at least have a piece of internationally agreed upon a terminology and words that a scientist could point to and say that this is what we are supposed to do. And the reason that she was afraid of the Soviet Union hiding evidence of extraterrestrial intelligence is actually linked to the first story of a false alarm in SETI history that happened in 1965. And so I'm going to tell you that story of the first false alarm and why that eventually led to the need for development of post-detection protocols. So the story begins with this young man on the top. His name is Nikolai Kardashev. Some of you might remember his name from my last talk. Um, in the mid 1960s, Kardashev had just finished earning his PhD in astronomy in Moscow, and he was full of big ideas. This man on the bottom is one of his mentors, Joseph Shklovsky, who you might also remember from our last talk. He was a very well-known professor of radio astronomy and, in fact, wrote one of the first serious books on the search for life beyond Earth, which was just then being started to be called SETI. Shklovsky encouraged his students to explore these big questions too. At this time, the United States was already making headlines with SETI experiments, like the first SETI experiment we learned about last time, Project Ozma. The Soviet Union didn't want to be left behind, especially since this was also during the space race, right? When the US and the USSR, I apologize, when the US and USSR were competing in space exploration. So in 1965, it seemed like the perfect time in the Soviet Union to start looking for alien life. Kardashev had an idea that was very different from the American approach. In the US, Frank Drake had started Project Ozma, which was very simple. You point a radio telescope at nearby stars and you hope that you happen to catch a signal coming from an alien civilization that might live there. Kardashev thought, well, it was an interesting idea. It was basically a waste of time because it'd be like searching for a needle in a haystack. It was very unlikely that you'd happen to point at the right star at the right time and happen to catch a signal. So instead, he dreamed up something much bigger. He imagined super advanced civilizations, ones far more advanced than our own. He believed that if they were out there, they wouldn't be sending tiny, quiet signals. Instead, they might build giant beacons in space, bright, powerful signals that no one could miss. So he wrote this paper where he tried to figure out what those signals might look like. He studied which radio wavelengths would work best in space and decided that certain frequencies, where the rest of the Milky Way was naturally quiet, would be the best place to listen. He also thought about power. The more powerful a civilization is, the stronger their signal might be. So he believed that the most advanced civilizations, what he called super civilizations, would be the easiest to detect because they'd have technology to send out massive, powerful signals among the stars. And we learned about this last time. He created something called the Kardashev scale, a way of ranking civilizations, potential civilizations, by how much energy they would use. And he imagined different types of civilizations and argued that looking for the type 2s and the type 3 civilizations would give us a better chance of success if we ever really wanted to find evidence of aliens in the universe. And in the end, his ideas really helped shape the approach for how the Soviet Union wrestled with SETI. In Kardashev's view, the most advanced civilizations on his scale would be using mind-boggling amounts of energy, comparable to what we see coming from exploding stars or giant galaxies. So he asked a very important question. If we see something that bright out in space, how do we know if it's natural, just there's a lot of high energy, bright, exciting things in space, or something that's built by an intelligent alien life form? He decided that we should look for signals that are very small and focused, so small that they'd take up almost no space on the sky, and especially ones that change over time, like a light blinking on and off. That kind of flickering might suggest that a message was being sent. And at that time, in 1965, astronomers hadn't yet seen any stars or objects outside of our solar system that gave off changing radio signals like that, except for one old supernova that was only changing in the sense that it was fading over time. Certainly nothing blinking or changing in a lot of exciting ways. But Kardashev thought that if a signal changed in a regular way, it could be a really big clue that it was artificial and made by technology. So he looked at a catalog of sources that we already knew existed, and he thought that there were two strange sources on the sky, CTA-21 and CTA-102. They were very compact, and they had a radio fingerprint that didn't quite look like normal cosmic sources. And in fact, the signal coming from CTA-102 looked a lot like what Kardashev thought a message from an intelligent civilization might look like. Ideally, he was looking for something that was not having been seen in the radio sky. And no one had yet observed anything that showed regular repeating changes. And this is what scientists call periodic intrinsic extragalactic variability. It's a mouthful, but we can break it down. So first, variability. What does that mean? It simply means that something out in space is changing over time. That can mean how bright it is, how much energy it's giving off, and there are lots of natural reasons for things in space to change like that. For example, like the picture you see here, sometimes dust or planets pass in front of a star, and if you're looking at that star, it will block some of its light for a little bit, so it'll kind of look like it's blinking at you. Sometimes stars experience star quakes or flares, a big release of bursts of energy, like our own sun does this in solar flares, right? Of course, there are supernovas, which is when a star explodes, causing a big bright flash that slowly fades away. But all of these are either one-time events or random, not very regular. So what would be special about periodic intrinsic radio variability? Periodic means it happens in a regular pattern, right? Like a ticking clock. Intrinsic means that the change is coming from the object itself, not something like passing in front of it, right? And radio variability means that these were all happening in the radio part of the electromagnetic spectrum, the part where astronomers were using radio telescopes to observe. So naturally, people wondered, could regular repeating radio signals be solid evidence of something artificial, something made on purpose by aliens? Like, in other words, is that evidence that ET is calling? A great example of why this was not the case, why something that is intrinsically, periodically variable in the radio would be a pulsar. Take a little picture here on the left. A pulsar is a type of star that gives off a very steady rhythmic radio pulses, like a cosmic lighthouse. They flash at regular intervals, sometimes even like by seconds, and they're incredibly regular. And in fact, they're so regular that when they were first discovered, they actually called them LGMs, little green men, because they thought it might be evidence of extraterrestrial intelligence. But their discovery didn't happen until 2 years after 1965. In 1967, by this young lady here on the right, Jocelyn Bell Burnell. So no aliens, still a really cool discovery, and a perfect example of how there really is periodically intrinsic radio variability in the natural world. But again, this is in 1967. They didn't know that yet when Kardashev was first putting out his theory. So after writing his paper on supercivilizations, Kardashev directed a graduate student at the Sternberg Astronomical Institute in Moscow. This guy here, his name is Gennady Sholomitsky. He told him to observe CTA 102 for evidence of that periodic intrinsic variability, which he believed would be further evidence that one or both sources could be the product of those alien supercivilizations. Again, here assuming that since there was at that time no known observable variability in the radio, that would be evidence of artificiality. Sholomitsky made his initial observations using a military facility in the Soviet Union, a deep space tracking antenna in Yevpatoria in Crimea, and shockingly discovered in CTA 102 evidence of radio variability. In fact, not just variability, but periodic with a period of about 100 days, so kind of flashing every 100 days. To put that discovery into context, astronomers would have been shocked to have found radio variability which varied over a period of years, let alone days. Therefore, Sholomitsky's discovery had the potential to make a really big impact in astronomy, completely transforming our understanding of the radio universe, even outside of the context of SETI. In April of 1965, Sholomitsky announced his discovery through a telegram submitted through the CBAT system, which quickly gained attention from astronomers all over the world. So what is a CBAT system? It's pretty cool, actually. Imagine that you're an astronomer who's just spotted something strange in the night sky, like a new comet, for example, or maybe something even more mysterious. The clock is ticking because the Earth is turning. So pretty soon that part of the sky is going to disappear from your view. If you want someone else to confirm what you saw, you have to let them know fast before it's gone. That's why astronomers back in the 19th centuries, that's the 1800s, came up with a clever solution. In the days before email or the internet, they sent astronomical telegrams. A special office called the Central Bureau for Astronomical Telegrams, or CBAT, was founded in 1882 to help astronomers around the world share urgent discoveries. If someone saw something new in the sky, they'd send a telegram with the key information, where to look, when, what it might be, so others could check it out right away. CBAT served two big purposes. One was verification. Other astronomers could double check what you saw. And two, credit. If you were the first to report something like a new comet, there was a chance it could be named after you. That was pretty common with comets. Or you would just get the prestige with having made a new astronomical discovery. It was good for your career. Credit is important. These telegrams could be very short, just a few lines, or longer with extra details and background. And over time, these expanded into bulletins and circulars. They're not really used today anymore because there's so many other forms of instant communication. But during the Cold War period, these telegrams had become a regular and trusted way for scientists to talk to one another. That's actually why, if you read the long form version of the post detection protocols from the 80s, actually they were directed to use the CBAT system to first share information of the detection of extraterrestrials with scientists around the world. However, during the Cold War, science wasn't just about discovery, it was also caught up in politics and secrecy. In the Soviet Union, many radio telescopes weren't just used for astronomy. They were used by the military and used for things like tracking missiles or downlinking with spy satellites. Because of that, what happened at those observatories was often kept secret even from other scientists. Since Sholomitsky had used a military radio telescope in Yevpatoria to study CTA 102, he actually was not able to publish full information about the telescope he used, what wavelength he observed at, because it was all classified. This made scientists in the Western world, in the United States, pretty skeptical of what he had found, especially because it had never been seen before. In fact, one American astronomer, Ken Kellerman, you can see here, wrote a paper basically saying that he was pretty sure it was hard to believe that this had happened because nothing was known about this telescope and the Soviets weren't reliable. So in other words, secrecy got in the way of science. Again, right, this all comes back to trust. Now, eventually, Western astronomers did confirm that CTA 102's signal changes over time, just as Sholomitsky had said. But by then, years had passed and the field had moved on. Sholomitsky didn't get credit for being the first. And his story is an interesting reminder of how hard it can be, how hard it was for scientists on either side of the Iron Curtain to share discoveries, and how sometimes good work got overlooked simply because it came from the wrong place or at the wrong time. Now, not long after Sholomitsky sent out his telegram about the strange behavior he observed in CTA 102, a group of Soviet scientists, including Nikolai Kardashev and Yosef Shklovsky, were chatting informally after a lecture at the Sternberg Astronomical Institute, which you can see here. During that conversation, Kardashev casually floated an idea. Maybe this was actually evidence of those super civilizations he thought might be out there. Well, that comment was overheard by a reporter named Alexander Midler, who worked for TASS, the Soviet Union's official state-run news agency. TASS didn't just provide news for domestic outlets like Pravda, it also fed stories to the international press. And Midler, upon hearing from a Soviet astronomer that they might have just discovered a super civilization from, of extraterrestrials, didn't waste any time. The very next day, April 12th, 1965, TASS released a dramatic news bulletin. You can see it back there in the background, which I've translated here in the front, with the headline, "We are signaled by a friendly alien civilization." The telegram opened with a bold claim. It said that radio signals detected from an object in space might belong to the technology of a highly developed extraterrestrial civilization, declare Moscow astronomers. Midler's report was divided into 4 parts and leaned heavily on Kardashev's earlier paper on extraterrestrial transmissions. He quoted Kardashev's point about how if the signal wasn't natural, it would have to come from a very compact source, small in size but packed with energy, which this was. He also mentioned how the object had that strange behavior, how its signal faded and then brightened again, and he compared it to a distant lighthouse, an image kind of meant to evoke something artificial or purposeful to send a signal. And to make the story more credible, he emphasized that other top astronomers, including Joseph Shklovsky, had been working to verify the data. And the telegram concludes rather dramatically saying, "The scientists have no doubt we have a matter which may be one of the most outstanding discoveries in the history of radio astronomy. Nikolai Kardashev believes a super civilization is discovered." This moment became one of the earliest and most dramatic public announcements suggesting contact with intelligent life. And it all began with a comment made in passing. The TASS telegram, which really confirmed that the idea of a changing radio signal meant that it was artificial, which we know is not true, but that was the understanding at the time, caused a huge stir in the press. The very next day, a press conference, was held at the Sternberg Institute. It seemed that the scientists in question weren't quite prepared for the media frenzy. Josip Shklovsky later wrote in his autobiography that the courtyard outside the institute was packed with sleek foreign cars, and about 150 top journalists from the Soviet Union and around the world had showed up to hear more. Shklovsky had been far more skeptical of the whole alien hypothesis. He later wrote that he had been quite annoyed with Kardashev, joking that he had been full of adolescent optimism, thinking that CTA-102 might be evidence of extraterrestrial life. And in fact, at the press conference, he scolded TASS and the journalists for jumping the gun, saying, "It is our right to ask journalists that they respect their great responsibilities, which does not always happen." So, in short, what started as a quirky scientific theory and a quiet conversation quickly became a media circus, and not all of the scientists were thrilled with how fast the story had spun out of control. Even though the Soviet scientists like Shklovsky and Sholomitsky tried to back away from the idea that CTA-102 was definitely a message from aliens, the story had already caught fire. People from around the world got excited by the idea that the Soviets might have made contact with ET. In fact, Frank Drake, who did Project Ozma, even sent a congratulatory message to the Soviets and asked them for more details. But behind the scenes, American scientists at the California Institute of Technology, Caltech, had actually been observing CTA 102 themselves. And they had determined that actually it was not an alien supercivilization, but a really faraway object called a quasar, which is an early galaxy that gives off really, really bright, strong, and active radio emission. In fact, they had even published an article in a journal pointing out that CTA 102 was one of these objects, but because of Cold War rules and slow publishing processes and censorship, that information had not yet reached the Soviet Union, and so they did not know about it. In the meanwhile, as I'm sure you can imagine, newspapers went wild. One of the UK's most famous astronomers, Sir Bernard Lovell, told a reporter that it was rather sad that the Soviets had jumped to such a silly conclusion. That had dealt quite a serious blow because Lovell had helped the Soviets earlier in the space race and was very respected in that country. So for him to publicly state that they should be embarrassed or ashamed was a really big deal. The New York Times also ran stories that made fun of the Soviet team. And so the Americans were painted as careful and scientific, while the Soviets were seen as jumping the gun and maybe even being a little ridiculous. Today, almost no one remembers the CTA 102 incident, but back in 1965, it really was a huge global sensation. Even Isaac Asimov, the famous science fiction writer, chimed in with an opinion piece in the New York Times. And believe it or not, the American rock band The Byrds actually wrote a song about it called CTA 102, and I have some of the lyrics there. It is, in my opinion, a truly terrible song. It's not a good song. And I will try to play it for you, but I'm going to try to play it at the end of the talk in a bit, just because in case I try to play it and then I can't get my slides back, it'll be a mess. But I'll try to play that for you at the end. So anyway, the point is that this story was genuinely everywhere, from your local newspaper to on your radio. People were genuinely buzzing about the possibility that we had just heard from aliens, even though it was pretty quickly shown not to be the case. And then, of course, from the perspective of the global scientific community and the media, Soviet science came out of the CTA 102 affair looking foolish. Now, that was a serious problem. During the height of the Cold War and the space race, the Soviet Union was deeply invested in maintaining its reputation as a scientific and technological superpower. So any public misstep like this had the potential for serious consequences. And that's why it's helpful to just pause for a minute and look at this story from the perspective of the journalist involved, Alexander Midler. So Midler, again, a reporter for TASS, the Soviet state news agency, he actually later wrote about what happened from his perspective. He had attended this lecture at the Sternberg Institute, just trying to get new and interesting scientific information he could publish about. And he, had overheard Nikolai Kardashev and Yosef Shklovsky discussing the possibility of alien super civilizations afterwards. And of course, Kardashev's speculation that that was an artificial signal. Now, critically, the day he overheard this was April 12th, or Cosmonautics Day, as it was known in the Soviet Union, the anniversary of Yuri Gagarin's historic first space flight. He was the first man in space. Now, in the USSR, symbolic dates like that and anniversaries were really important. So the timing of, this potential discovery of extraterrestrial civilizations happening on Cosmonautics Day, the anniversary of the Soviets putting the first human being into space was a really big deal. It almost seemed like too coincidental to be, like magical almost, right? So it was really important that he rushed to publish the story. Framing potential first contact with the Soviets and importantly beating the Americans to it. The Soviets could be the first people to communicate with another world on behalf of Earth. Really important in the context of the space race. So that was why they were in a hurry and they didn't do all their fact checking. But once it became clear that the signal was more likely natural, a quasar as we know it is today, and once Shklovsky had made those kind of less than kind remarks about journalists in an international press conference, Midler panicked. He feared for his job, maybe even his life, right? This is back in the days when people were thrown into gulags. In the Soviet Union, a scandal that embarrassed Soviet science on such an international level could have serious consequences, especially for those in state media. Now, this is where Yosef Shklovsky kind of has a little bit of a soft spot. Shklovsky had lived through Stalin's Great Terror in the 1930s. This is a period in which Joseph Stalin, the leader of the Soviet Union, had been incredibly paranoid and killed and imprisoned in the Gulag many, many people, including about 1/3 of all of the astronomers in the Soviet Union during this time period when Joseph Shklovsky was just a grad student. So he really understood state violence and the consequences of that. So he took Midler's fear, his concerns, seriously. So to try to diffuse the situation, Shklovsky acted quickly. The very next day, he published an editorial in Pravda, which was, of course, one of the Soviet Union's most important newspapers. In it, he praised Soviet technology, he highlighted the genuine scientific discovery of radio variability, and he framed Kardashev's alien speculation as one potential hypothesis out of many. He emphasized that much more evidence would be needed before such an extraordinary claim could be accepted, but still left the door open for future investigation. It's probably not aliens, but we don't know for sure it's not aliens, so it's not such a crazy thing to say that it might have been. Shklovsky's editorial was careful, diplomatic, and strategic. He avoided placing blame. He kind of validated the excitement around extraterrestrial life and the natural scientific discovery and helped protect everyone involved, including the journalist Alexander Midler. And so, in the end, thanks to the political savvy of the scientists involved, Midler kept his job and didn't get sent to the Gulag. The observatory wasn't shut down, and the Soviet SETI program was able to carry on, not totally unscathed, but with the potential to do good science down the line. So in the end, although it did cause some embarrassment, the CTA 102 affair didn't stop the Soviet search for extraterrestrial intelligence. The story was reframed, damage contained, and scientific work able to continue. Nevertheless, the fallout from this early false alarm in the search for extraterrestrial intelligence made it clear that scientists needed a more thoughtful, coordinated, and trustworthy process for announcing possible discoveries. As Jill Tarter later cited the CTA 102 affair as being one of the reasons why she pushed for the development of the SETI post-detection protocols in the 1980s, she was concerned that if such an event happened again, especially in a politically sensitive setting like the Soviet Union, Governments might suppress the discovery to avoid embarrassment, right? The Soviet Union wouldn't want to make the same mistake again. So rather than sharing the information and risking humiliation, they would just try to keep everything top secret and under wraps. And more broadly, the public might lose trust in scientists if discoveries were rushed, overstated, or poorly communicated. So at its core, the post-detection protocol effort is about trust within the scientific community so that they can trust each other, just like, Sholomitsky's original telegram wasn't trusted by Americans, between nations, right? And then with the broader public. We want the public to believe scientists. And so in order to do that, they must be trustworthy. They must present good information. So if we ever do detect a real signal, we'll need that trust in order to verify it, understand it, and respond to it responsibly. The CTA 102 affair made it clear that scientific discoveries don't happen in a vacuum. They happen in political, cultural, and media environments. And that means careful communication matters. Scientists have to take care in how they share early results, especially when the implications are profound and uncertain. And we see this play out in a lot of other areas besides the search for extraterrestrial intelligence, right? We see that in the COVID-19 pandemic. This careful dissemination of scientific information was really important. So we have learned and continue to learn from these early missteps. And now that the SETI community is, building the establishment of clear protocols and a commitment to transparency, we'll be better prepared to handle, verify, and share any future signals with confidence and care. And then hopefully the public will not have to fear that we are locking aliens away in secret government, basements, and instead are being transparent and trustworthy. And with that, that concludes my presentation, and I'm super excited to talk to you guys about this.
I have a question.
Sorry, I'm struggling with my mouse. Oh, there we go.
Sorry, lost my voice a little bit.
Do you have any thoughts on the comet that's supposed to be coming like this fall that they're saying could
Three-Eye
be?
Atlas.
Yeah.
Yeah. So Three-Eye Atlas is an I'm just going to repeat it for people who are not aware of what it is. It is an interstellar object. What that means, it's an object that we can observe coming into our solar system that is we know is from interstellar space. So from the space between stars, really far away, in other words. Now, actually, at my old workplace, so I used to work at the Harvard Smithsonian Center for Astrophysics, and one of my colleagues there was a man named Avi Loeb. And Avi has popularized the idea that objects coming from interstellar space could potentially be extraterrestrial spacecraft. He first posited this actually when I was working there with another interstellar object called Oumuamua. So you might remember that. It was kind of the cigar-shaped object that came from interstellar space. We've only seen two of them so far, right? This one and then Three-Eye Atlas. So they're rare. And now Avi has really popularized the idea that these could be spacecraft. I will responsibly note that most of the astronomy community disagrees vehemently with that. And it's not because it can't be. It could be. It could be evidence of an extraterrestrial spacecraft. But it's far more likely that it is like things like a comet, or kind of interstellar debris that got flung off in some kind of massive violent event, like a supernova explosion, for example. There's so much violent activity in space that have you ever heard of the phrase Occam's razor? Kind of like if there are two possibilities, it tends to be the simplest possibility that is the correct one. We're likely dealing with a situation like that. Like it is probably just some piece of rock or object that is the result of some sort of violent, galactic event. That being said, we don't know, right? There's always the possibility that people like Avi in their speculation are correct. So the way that the astronomy community generally responds to this is to say, we think it's probably not. Is it worth devoting some resources to investigating whether or not it is? And the answer to that is yes. People like Avi Loeb have established organizations like the Galileo Project, which do try to point radio telescopes, for example, at these objects to see, are we detecting any radio signals that might be coming from instrumentation on board, right? If it is a spacecraft. So far, the answer to that has been no, we haven't seen anything like that, but time will tell. It's very interesting. One way or another, these are very interesting objects because they come from the most distant parts of our galaxy. So one way or another, we're learning something cool.
Thank you.
Yeah. I can speak a little bit more to that if there's not immediately a question, which is just to say that it does kind of come back down to this question of trust in science, right? Which is scientists are always balancing, kind of doing a careful balancing act, which is to say that, like, on the one hand, you don't want to discredit any potentially thrilling and exciting discoveries, right? Like the detection of an extraterrestrial civilization or an interstellar spacecraft coming through our solar system. All of these things are possible and plausible, and it is in good scientific standing to ask those questions. But on the other hand, you don't want to constantly throw out wild and crazy ideas that never come to fruition, that you don't properly investigate, because then why would anyone believe anything you say? You have to back it up with evidence and data. And so it really all comes back down to, again, establishing trust in the scientific process by being transparent, by showing your data, by doing the work. And that's just the backbone of science.
I read yesterday that they were leaning towards it being something because it seemed intelligent in its movements or how it is moving.
Yeah, so that's
So I thought that was kind of interesting.
Yeah, that's super cool. Like that's one of the most fun things about being alive today is that we have all of this instrumentation on our planet that we actually can devote some time and resources to, like, looking carefully, right? Like there's almost no other period in human history where something like that would come through our solar system and we would be able to do anything intelligent about it. But now we can do things like carefully monitor it, look for radio communications, look for strange movements. And yeah, it's just we're kind of in like this really incredible point in human history where we actually can ask these questions and potentially get answers.
Right.
Any other questions?
I'm not seeing any in the chat. No. Oh, wait. What was the one? Someone said very interesting.
I know a lot about the search for extraterrestrial intelligence and astronomy, so you can really throw anything at me. Oop.
Hey Marie, you're on mute if you're talking to
I
us.
wasn't sure if she was trying to talk
Sorry.
to me or someone else.
No, I'm just talking away. Um, I find this interesting, but I always kind of thought that the chances might be there of, you know, aliens visiting Area 51 because there was such a huge leap in technology after that whole time frame came. Does that make sense?
Yeah, I
It's
absolutely
kind
know
of
what
like
you're
how did
talking
we leap from barely knowing how to fly to
about. Yeah.
everything right after that? This seemed like a huge boom.
It's a fantastic question. And so these are the kind of questions that people, like, in my field ask. Like, we're historians of science. We're looking at how progress tracks over time. And it's like, so obviously aliens is a fun answer to that question. But the probably correct answer to the question is actually maybe a bit more dull, but I actually find rather exciting, which is to say it's actually the way that our governments acted radically changed around this time. So during World War II, it became really clear that the nature of warfare had completely changed, right? Suddenly, you were going to win if you had the best planes or the best bombs, basically science and technology, right? It wasn't simply about like who had the most men who were trained in the best fighting techniques. That just like wasn't where war happened anymore, right? It happened in the sky, it happened under the sea with submarines, and so because of that, after the end of World War II, government started really heavily investing in what we call R&D, research and development. And oftentimes that meant basic investments in kind of pure science, like science that didn't have an obvious application, but like might make discoveries that would be huge breakthroughs. And that's kind of how what happened with like Project Manhattan, the development of the nuclear bomb. And in fact, at the end of World War II in 1946, there was this man named Vannevar Bush who actually wrote this memo called "Science: The Endless Frontier" that actually led to the establishment of the National Science Foundation. So this is the gigantic funding body in the U.S. federal government that funds millions and I mean hundreds of millions of dollars in science each year, and it started right then. So I think the real reason we start seeing crazy abilities like in technology, in flight, in machinery, in scientific progress around that time is because there was suddenly that just like a massive government investment in it. Like people were quitting their jobs to go back to school to become physicists because suddenly there was so much money in that field. And so in some ways, it is alien technology, but it's like our own alien technology. Like we just like suddenly had all of these resources to be able to do that. And it's actually a huge testament to the foresight of the people who created those institutions because they recognized that in order to be kind of like the most powerful country in the world, it wasn't enough to just like have good values or morals. I mean, those things are important too, but really to just invest in scientific infrastructure because there's so much utility that comes out of that. Like not only from a this is interesting and cool and we're learning about space, but also like a lot of those tools and technology had those direct applications that could be used in warfare, that could be used in like just being a leader in the world in a certain area. And so that's really what changed the landscape at that time more than anything. I wish it was aliens. This is the thing with science. There's no evidence that that's the case. And so we always, there's a concept in science where you can always prove something does exist, but you can't prove something doesn't exist, right? Like if I have an apple on the table, I can observe its color, I can weigh it, I can just determine its mass, I can put a microscope over it and see its composition, I can prove that it is there. But can I prove that there is not an apple on Mars? I can look, right? I can look at the Martian surface with all of the best, highest equipment. I can send people to Mars to like lift up rocks and but there's always a place it could be that I haven't looked yet. So you can always prove something does exist, but you can't prove it doesn't exist. And so that's what's really tricky with aliens. We can't ever say they aren't there, for sure.
Well, thank you. It's been a pleasure to listen to
Yeah,
you. So
sure. This
thanks.
is really fun. I mean, I love talking about this.
All right, if there's no further questions, we'll make sure we send your email out, Rebecca. And we want to thank you for all your time today. Thank you for this wonderful presentation.
Yeah, thank you so much. Thanks for having me back. I'm glad I could share more.
Of course, of course. Well, have a great day, everyone.
Thank you.